Good morning, good evening, or good afternoon, whenever it is you're watching. Thank you for watching. Today we're going to be covering section 6.4, Modern Periodic Table. It is Thursday, October the 22nd. And let's get started. We are working again with fifth period. Thank you, fifth period, for helping me out. We're going to start our lecture today by talking about dictionaries. Okay, so let's talk about how has the English dictionary evolved or changed over time, right? Evolve means change. So, Oscar or Irvin, I don't know who should help me read. Oscar or Irvin, because Alexia has been reading all week.
I'll read it, miss.
Thank you, sir.
Language changed with time. New words enter the language and old words often disappear from the lack of use. Dictionaries are published so that people can keep up the change in language and know how to use words properly. These publications may be in print as is the law dictionary below, or they may be electronic. Dictionaries can be found on the internet and apps are available for smartphones. Dictionaries are
Invaluable.
Good, valuable communication.
All right. So dictionaries are invaluable, right? They're very, very important, especially for your English classes when you're writing those stories or those poems that they ask you to do. Now, the English dictionary is always changing. Some words that aren't used anymore, they get removed. Some words are created, so they get added. The periodic table is very similar, except we don't delete elements, right? Elements, once they've been discovered, get added to our periodic table, and it just continues to grow and grow and grow. The first periodic table, when it was published by Mendeleev, only had about 60 some, 65 or 63, I don't remember. And 100 and some years later, right? It was in 1870 that it got published. We're 2020. There are now almost 120 elements. It's, to be exact, I think it's like 118. 118 elements are now on our periodic table. That's almost double the number of elements since Mendeleev. And I'm pretty sure in the next 150 years, when I'm long gone and you guys are old and gray, you guys will probably, well, maybe not. You guys will probably be gone too. But either way, the periodic table might be twice as big as well. We don't know, right? We don't know what the future holds. So that is our topic for today, the ever-changing periodic table. All right, so here you have, let's get started. The modern periodic table, well, has changed. Has changed since the time of Mendeleev and Moseley, right? When Mendeleev created the periodic table, there was only 60. When Moseley, I'm sure there was a couple more, and now 118 elements later. Many new elements have been discovered, while others have been artificially synthesized. Does anybody know what artificially synthesized means? Anybody have an idea what it means if something has artificially synthesized? Artificially synthesized means that it wasn't discovered. It's not a natural element. It's a made element, a man-made element that is created in a laboratory. Okay. Each element fits properly into a group with similar properties. The periodic table has changed in the arrangement. When Mendeleev created it, it was by atomic mass. And then Moseley came around a couple years later, 30, 40, 50 years later, and changed it so that it's ordered by atomic number. Why did he change it? Because it fixed the little problems that Mendeleev's version had. Elements are grouped together because of their similarity in the chemical properties, in vertical groups or in columns. And And this was all Mendeleev's version, right? Mendeleev was that first one to start to group them by similar properties. Moseley was the one who rearranged it by atomic number. Now, let's talk about the figure below. And the figure below is just a periodic table, another version of the periodic table. The figure below shows the most commonly formed, the commonly used form of the periodic table. Each square shows the chemical symbol of that element along with its name. Well, technically, this one doesn't have the name, it only has the symbol. Notice that there are several symbols that seem to be unrelated to the name. We already studied elements, right? We know that some of those names those elements have been around for a very long time. And have symbols based on their Latin names. For example, iron. Iron is, excuse me, iron has a symbol of Fe. Why? Because of its Latin name. Lead is the same thing. It has a symbol of Pb because of its Latin name. And you always have to remember that the number that's written at the top is the atomic number and represents how many protons are in that element. If I were to ask Oscar or Irvin how many protons are in carbon or nitrogen, all they have to do is look at the number on the top of the symbol. All right, so Oscar, how many protons does carbon have? The letter C. How many?
6.
Right. Irvin, how many does nitrogen have? What's the number on top of nitrogen, Irvin? Irvin, are you there?
15.
15. What's the number on top of N?
Plus.
It's 7, right? And then and then for oxygen, how many would it be? Anybody? How many protons for oxygen, guys? 8, right? We know that there's 8 because there's a number 8 on top of it, which is the atomic number. All right, and we can do that. And we can do that for every single element on this periodic table. All right, now let's talk about a period. A period are for the periodic table, it runs 1 through 7 and they go across, right? There are 7 rows or 7 periods on the periodic table. Each row, each new period begins with a new principal energy level where electrons get filled. And what am I talking about? I'm talking about this, guys. You see these circles? These are energy levels where electrons orbit around the nucleus. So this is energy level number 1 or period 1. Here you have period 2, period 3, and so on and so on and so on. That's where you find electrons. Okay? So the maximum number of energy levels for the periodic table is 7 right now. It'll probably change in the next 50 years. Who knows? The only thing that you have to remember is the energy level. All right. All you got to know is that every new period is a new energy level where electrons are found. Period 1 has 2 elements, hydrogen and helium. Periods 2 and 3 will have 8 elements. Periods 4 and 5 have 18 elements, right? Because there's 18 groups. Now, let's talk about periods 6 and 7. Why do they say that that it has 32? Why does it say that it has 32? When if I count these boxes right here, there's only 17. Where do they get that number 32, guys, from? Anybody know? Anybody see it? How come I have here 55, 56, and all of a sudden it jumps to 72. What's missing in between barium and hafnium? What's missing between 88 and 104? Radium and I think it's ruthenium, if I remember that RF correctly. What's missing? What's missing that goes here and can help us remember? What do you notice that's here, that's missing in these two little blocks right here? What elements? These are your elements right here. These lanthanides and actinides, technically, they should fit in between these elements right here, making our periodic table very long. Okay? Oh, don't pause. Okay, let's go back. Here. Turn that off. Okay, there we go. A period is a horizontal row of the. Oh wait, where was I? Yes, this is the reason why there's 32, because it starts at 55, 56, it jumps to 57, all the way to 71, and then it continues from 72 to 86. Those are all the elements in period 6. For period 7, it starts at 87, goes to 88, it drops down to 89, all the way to 103, and then 104 to 118. Those are the 32 elements for period 7, okay? They remove those 2 rows so that it makes the periodic table smaller, so it's easier to fit on one page. A group is a vertical column of the periodic table based on the organization of the outer shell electrons. So those outer shells, those outer electrons, are based off the group numbers 1 through 18. And let's talk about that, because here it only shows 1 through 18. If you were to look at the periodic table that I have uploaded, you'll see that there's 1 through 18, and all of a sudden you see 1A, 2A, 3B, and then 3A. And why do they do this? Well, let's explain that next. There are 2 different numbering systems, and they are used to designate the groups that you should be familiar with. In the United States, we use the traditional system. We use letters A and B to differentiate between different groups. The United States makes things harder. The first 2 groups are 1A and 1B, while the last 6 groups are 3A through 8A. And here you could see them, guys. 1A, 2A, 3A, all the way to 8A. The middle groups use B in their titles. So we have 3B, 4B, 5B, 6B, 7B, 8B, 1B, 2B. The United States it doesn't go into detail. Some people just think it's easier to identify the valence electrons if we use it. And that's something that we'll talk about later. We're not going to talk about it just yet. Unfortunately, there was a slightly different system in place in Europe to eliminate confusion. The IUPAC, which is the International Union of Pure and Applied Chemistry. So it's all these chemists from around the world. They come together and they decided to use a simple numbering system for the groups. They use just 1 through 18, which is what I use because everything else is just way too complicated. Most periodic tables have both, like you see here. You have both numbering systems, 1 through 18 on top, and then the English system on bottom, or the United States system. Most recent depictions of the periodic table show an incomplete 7th period. So most periodic tables, they don't have these 118, 117. They usually stop at like 107 or 104 or something like that. But there are 118 elements recognized by the IUPAC. Many elements have been synthesized. They're made by adding neutrons and alpha particles into the nucleus of elements. For example, uranium. Uranium is nucleus gets fused together with small elements to create elements 93 to 100. Okay. And here you have 93 is newtonium, plutonium, americanium, curium, berkelium, californium, einsteinium, and fermium. All of these elements are made using uranium and smaller elements from the periodic table. Most of the time, these elements are very unstable, so they don't last very long. They only stay together for about a second. So we don't know a lot about their chemical properties. Elements up to atomic number 112 are known, not in detail because it doesn't last long. And some evidence for elements 13 and above have been put forth. Elements 114 and 116 have been added on the table in 2011. In 2015, the IUPAC verified and acknowledged the existence of elements 113, 115, 117, and 118. So that are now on our periodic table. And if you want to know a little bit about those elements, well, let's just go through it real quick. Element 113 is called nihonium, symbol NH, and these Japanese researchers named it after the Japanese word nihon, which means Japan. Scientists from Russia and United States named elements 115 and 117. 115 is called moscovium. The symbol is MC, which is named after the Russian city Moscow. Element 117 is named after the state Tennessee. It's called Tennessine, and the symbol is TS. Now, this is the one that always gives me problems. It was discovered by a Russian team. It's element 118, and its name, I cannot pronounce it. This is already the fourth time that I've tried to pronounce it and I can't. Oganesson. I don't know. Symbol OG after a famous scientist, Yuri Oganessian, a element hunter. Okay. So here is the video that we're going to end our lecture with. I like it because it talks about the different groups of the periodic table. It doesn't go into detail about them, but it does tell you a little bit about them, and it shows you exactly using different colors where they're at. Periodic table trends is also in here. If it's just a little, we haven't talked about trends. Trends will be talked about next week. So just watch it. Try and see if you can understand those trends. If not, don't worry. We are going to talk about each trend in detail next week. Okay? All right, let's watch the video real quick. It's only 4 minutes long.
All right, so you've got the periodic table of the elements. Exciting, huh? Not really. I know that when most of you look at this, what you're really thinking is, ugh, what a frickin' headache. But don't worry, this monster's about to get a lot easier to handle. The first thing to know about the periodic table is what each of the pieces on each of the blocks means. Each block on the periodic table represents a different element. Each element is different than the others based on the number of protons it has in its nucleus. This is the number that is shown in the upper part of each block. The large letters in each block are the atomic symbol, or abbreviation for the name of each element. The number at the bottom of each block is the atomic mass of the element. This is a very important number for use in calculations. The group number, shown at the top of each column, divides the elements into 18 different families, each with similar atomic traits. A second group number is also shown above each column of elements. These are the numbers that are used most commonly when referring to groups. The elements of the periodic table are often grouped according to their nature. The group on the right contains all the inert elements, also known as noble gases. To the left of these are the halogens. Left of those, in a step-like pattern, are the nonmetals, which also include hydrogen on the left of the table. Below hydrogen, in the first column, are the alkali metals. To the right of those are the alkali earth metals. All of the elements in the B group are considered transition metals, including the rare earth metals. The elements that complete the right portion of the table are simply called other metals. Many periodic trends, or the tendencies of elements to express certain characteristics, can be observed on the periodic table. These trends include atomic radius, ionization energy, electron affinity, and metallic character. The atomic radius of an atom is the distance from the nucleus to the outermost electron shell. As one might expect, the greater the number of protons and the greater the number of electrons, the larger the atomic radius will be. The atomic radii of atoms increases as you move down and to the left on the periodic table. The ionization energy of an atom is the minimum amount of energy required to remove one electron. Generally speaking, the lower the atomic number, the higher the ionization energy. The observed trend is that the ionization energy of an element increases as you go up and to the right on the periodic table. Electron affinity is the energy gained by an atom when it gains an electron to form an anion. Another way to think of this is the energy required to remove an electron from a singly charged anion. Atoms with fewer protons have higher electron affinity. The trend can be observed that electron affinity increases up and to the right on the periodic table. Electronegativity is the ability of an atom to attract electrons to itself. Noble gases aside, the atoms on the right side of the periodic table are close to filling their valence shells and thus have high electronegativity in comparison with those on the left. The trend in electronegativity is that, in general, it increases the farther up and to the right an element is on the periodic table. The metallic character of an element is the tendency for an atom to lose an electron instead of gain electrons in order to fill its valence shell. As you noticed in the group classification of the elements, the less metallic atoms are on the right side of the periodic table. With this in mind, the trend can be observed that the metallic character of an element increases as you move down and to the left on the periodic table. Now that you know your stuff, don't let this big messy table give you a headache. Just relax, remember the trends, and you'll be fine.
All right, so those trends, I just wanted to get your feet wet. I wanted just to show you more or less a little bit about it, okay? Because we're not going to talk about it until next week, okay? So that's a topic. These videos, they will be added to tomorrow's assignment. And summary. Let's summarize today's lecture. The periodic table is arranged in order of atomic number thanks to Mr. Moseley. It was Mendeleev who put them by groups or elements with similar properties. A period is a horizontal row of the periodic table. Each period represents a new energy level where electrons fill or orbit. A group is a vertical column. I don't know why they called it a row, but it's a vertical column on the periodic table, and these groups are elements that have similar chemical properties, meaning they have a tendency to all react the same. Okay? Today's assignment, you will be doing questions 1 through 4. You are to skip questions 5. All right. Thank you for watching.